What's up guys, Ryan Tech here. Today I have this uh practice problem in physics and I'm going to be making a projectile on an angle video. So let's get into it. So as you see, and pause the video to see if you can figure it out. This question. Okay, so our initial velocity is 10 meters per second, our angle is 30 degrees, and we want to find the horizontal distance. So how do we even, let alone approach a type of question like this? First, let's list down our info. Okay, so our V initial is equal to 10, and our theta is equal to 30 degrees, and our V initial x is equal to 10 cosine of 30 degrees, and y, and this is the same reason for, okay, so 10 sine of 30. Okay, now how do we all of a sudden get the answer for V initial x and V initial y? Well, let me show you. So, as you see, we have, and I should probably be using a different color. Okay. So, I have this triangle here, okay? It's a right angle triangle. As you see, this is our right angle, and our theta is 30 degrees, okay? And this is vertical, our vertical side, so this is V initial y. Horizontal, so it's V initial x. And this is just V initial. Now in physics, this is like something you have to learn. In physics, whenever you want to say what V initial x equals to, it always equals to adjacent over hypotenuse, okay? So our adjacent side relative to theta over hypotenuse, okay? So V initial x over V initial of 30, V initial x over V initial, which is in fact cosine of 30 degrees. So that's why we use cosine of 30 degrees. Now, why do we have 10 cosine of 30 degrees or 10 sine of 30 degrees? Now, we add the 10 because our initial speed was 10, so that means we times 10. That's just kind of something you have to learn in physics, and if you don't memorize it now, then you probably want to pause the video, fully take it in, because you're going to use this a lot more. So now let's actually move on to the problem. So we have all our info. Now let's move on to the problem. So since we want to find the horizontal distance, and remember, whenever they ask for the horizontal distance, this is the formula you should use. Distance horizontally is equal to V, so our Vx, which is our horizontal speed, times the elapsed time, okay? So we know what this is, but we don't know what our time is. And if we figure out our times, then we could figure out this. Okay? So let's do that. Okay. So we have to use one of the kinematic formulas, and our kinematic formulas are V final is equal to V initial plus AT, V final squared is equal to V initial squared plus 2AD. Oh yeah, V initial squared. Oh yeah, and the second one and the third one is D is equal to V initial T plus 1/2 AT squared. Okay, and the last one is D is equal to V final minus V initial in brackets times T. Okay, so those are the four main 2D kinematic formulas. Okay, and of course, if we have constant speed on the x direction, we'll have Sx is equal to Vxt. In other words, horizontal displacement is equal to velocity times time. Now we realize that the only formula that actually works is this one. Okay, so let's use that. So, oh yeah, and I'll just keep this so we could remember it. I'll just delete the rest of them. Okay, so now we're gonna go and this is for the y direction, by the way. We're gonna use the y direction because on our x direction this formula doesn't work, so we're gonna use it on our y direction. I mean, it does work, but then our acceleration is gonna be 0, and then we're just gonna be left with v final is equal to v initial, even though that's kind of obvious. Okay, so, and we don't want that. We want our time to be there. Now, what's v final and v initial in the y direction? So we could in fact say y, and y. Okay, and we won't put a y for t because there's no such thing as horizontal or vertical time. Okay, we realize that our initial on the y direction for speed is 10 sine of 30 degrees. 30 degrees is 1/2 times 10 is 5. So this is equal to 5. Okay. Now, what we're gonna do is that we're gonna say, okay, what's our v final? Now, we gotta realize that when we have this type of practice problems, so when they ask us, we start here and then we land here, that means that v initial y is equal to negative v final y. So if you think about it, initially, we have a positive force going up, and then later, for our final velocity, we have a negative force going down, which is why that v initial y is equal to negative v final y. So that means since v initial y is equal to 5, that means that v final y is equal to negative 5. So v initial y is equal to 5, but v final y is equal to negative 5. Now, I'm gonna delete that. Okay. So now, what we're gonna say is that, okay, so now that we have that, we say, okay, so let's plug in our stuff. Negative 5 is equal to 5 minus 9.8. Now, 9.8, you have to memorize this. In physics, 9.8 is our gravitational pull, or our gravitational acceleration. So this is gravity, in fact. So when we say acceleration in the y direction for projectile motion, it's always going to be negative 9.8 meters per second, okay? So we have to memorize that this is the gravitational acceleration, okay? Now we're going to move this to the other side. So we're going to subtract negative 5 from both sides, and we get negative 10 is equal to negative 9.8 t. And then if we divide negative 9.8 from both sides, then we'll get the answer for t, which, drum rolls please, is t is equal to 1.02. And you can add the units second. So it's going to be 1.02 seconds, okay? Anyways, so now that we got through that, so let's quickly write it here before we forget. T is equal to 1.02 seconds, okay? Now we actually know that Sx, so we know that Sx, or our horizontal distance, or delta x, whatever you want to call it, is equal to Vx times t. Okay? And now we're basically all set. All we have to say is 10 cosine of 30 degrees, which is 5 radical 3, 5 radical 3 times t. So 5 radical 3 times t is equal to Sx. It's equal to our horizontal distance. Now we have to plug in t. So now we get Sx is equal to 8 0.83 meters. And that is it for this video. Thanks for watching, and as always, have a nice day. And I will actually be, if you haven't understood this video yet, then I'll be posting more of these projectile and angle practice problem videos. So have a nice day.